Good afternoon, pilot teachers, and good afternoon, students. Okay, thank you. Sit down. We are now ready to move on to looking at the third very important factor that contributes to what makes climate different from one place to the other, and that is pressure. From the previous lessons that we have covered so far, we have looked at temperature as one of those important factors which contributes to what makes climate different. We have looked at also the different reasons for what makes temperature different from one place to another. We also looked at precipitation, and we found out that precipitation is one of the important processes within the water cycle. We also had time to look at all the other processes that are within the important cycle known as the water cycle. From precipitation, we were able to look at the three types of rainfall, and they are orographic, cyclonic or frontal, and convectional rainfall. Today, we are going to move on to looking at the third important factor which contributes to what makes climate different, and that is information now on pressure. So if you look onto your booklet, Introduction to Climate, you will find on page 11 information now based on what we are going to cover on the topic on pressure. Pressure is the third important factor now that contributes to what makes climate different. We start off by looking at what is pressure or what is atmospheric pressure. From the chart, we note that the gases or the air, which is actually around us or in the atmosphere, they have weight. And because the gases or air has weight, it will definitely exert pressure. So when we talk about air pressure, it is basically looking at the amount of weight by air exerted on a particular area. So if air is actually exerted on a particular area, it is actually applying pressure to that area. And therefore, that area, we can describe it as having high pressure or low pressure, depending on the weight of air which is actually exerted on that area. The introduction from our booklet, if you look at the information from the booklet, it reads, the gases which make up the atmosphere, they have weight and so exert pressure. Atmospheric pressure at any point on the Earth's surface is the weight of the column of air above that point, extending to the outer limits of the atmosphere. Pressure, from what we have learned already on elements of weather, is expressed as a force, and therefore it is measured in millibars. An average pressure at sea level would be around 1,000 millibars. Low pressures are within the range of 950 to 1,010 millibars, and high pressures are typically between 1,010 and 1,045 millibars. Weather maps that shows lines joining places which have the same pressure at a particular time are referred to as isobars. Sorry, I'll rephrase that statement. It is not the weather maps, but it is lines on a weather map which joins up places having the same pressure at a particular time are referred to as isobars. And again, those information we have already covered when we looked at elements of weather. Let's move on to the information from the monitor there, which tells us about what is atmospheric pressure. And again, it gives us a simple definition of what air pressure is. In very simple terms, atmospheric pressure can be described as the weight of the overlying air. Air or gases that make up the atmosphere have weight. If we can recall, we're looking at percentage of the amount of different gases in our atmosphere. What percentage is carbon dioxide in our atmosphere? What percentage? Gideon, what percentage is carbon dioxide in our atmosphere? Approximately.
Approximately 0.04%.
Okay, approximately, we're looking at about 0.04% of all the air, gases in our atmosphere as carbon dioxide. How about oxygen? Anita, what percentage of the total air masses or air that we have is oxygen? Not air masses, but the air that we have is oxygen. We said carbon dioxide is approximately 0.04. How about oxygen?
21%.
Okay, approximately about 21%. How about nitrogen? Moses? Nitrogen, approximately what percent?
78%.
Okay, approximately about 78%. So you see, the air which is actually in our atmosphere, or the gases that make up the atmosphere, they have weight. And because they have weight, they also exert pressure on the area that they are exerted on. And that pressure that they're exerting on is referred to as air pressure or atmospheric pressure. The greater the amount of overlying air, the greater the weight that is exerted on the column of air beneath it. So if we're looking at this area here, and we're looking at the column of air exerted on that area, to find out what is the amount in terms of maybe millibars, we will need to have an instrument placed here so that we can find out what is the weight of the column of air which are above this particular instrument here. And then we can measure how much air is exerted by reading information from the instrument. So definitely, air has weight, and definitely when it is exerted on an area, it gives that area the pressure. Okay, we move on. Looking at the nature of atmospheric pressure, perhaps some of the important facts that we need to also remember when we are dealing with air pressure. Air is highly compressible, so that lower layers of atmosphere becomes compressed by the air above. This increases both the pressure and density of the lower layer. The layer or the air which is actually at the surface will have to be under the weight of the other air which are on top of them. Therefore, at lower level, we tend to find the pressure being greater, and as we getting higher and higher, the pressure decreases, because the weight exerted on the surface would be greater, and as we go higher and higher, that pressure then is released. Conversely, the air in the upper layers are not subjected to heavy compression, and therefore have less pressure and less density. Do we understand that? Do we understand that point? Yes? Okay, good. Pressure is highest at sea level and below. With increasing altitude, pressure therefore will decrease rapidly. In other words, at lower altitude, pressure is high. As we go higher up, pressure decreases. Why? The column of air or the area at lower altitude will have to withstand the weight of the air above it. But as we go higher and higher, the weight reduces. Therefore, pressure as we get higher up decreases. Do we understand that point? Yes? Okay, perhaps let's look at the chart here. And this chart here also will give us some of the important facts that we need to remember, so it helps us also understand high pressure and low pressure. We already found out that we can identify by looking at the instrument that is used for measuring air pressure to tell us whether an area has high pressure or low pressure. Any pressure that reads 950, between 950 to 1,010 millibars are said to be low. Any air pressure that are between 1,010 to 1,045 are said to be high. But what causes the high pressure and the low pressure. We come back now to this diagram here. From what we have already learned in science, perhaps, we know that cold air, because when we're looking at air pressure, it has to do with air. Cold air will always sink. Why? It is dense or heavy. And because it is dense or heavy, it will always sink. Warm air or hot air will always rise. When cold air sinks, it is exerting a lot of pressure on a smaller area. Therefore, that area is said to have high pressure. So cold air is associated with high pressure because cold air will always sink, and when it sinks, it exerts a high pressure on the area it is sinking on. Warm air or hot air will always rise, and because the air is rising, it relieves that pressure on that area. Therefore, the area will said to have a low pressure. So warm or hot air is associated with low pressure areas. Cold air is associated with high pressure areas. The sinking of the cold air will result in a high pressure area. The rising of the hot air or the warm air will result in a low pressure area. Another important point to remember, when all of those air is actually sinking, if we imagine that this is the land surface, what would happen to the air which have already sunk and hit against the surface? Does it stay here or does it infiltrate into the ground? Like in the case of water, infiltration? No. What will happen to the air if this is a solid surface here? It will obviously move to the side or to the other side. And the movement of any air, surface air, is referred to as wind. So wind is simply the movement of air from high pressure areas to low pressure areas. So the air sinking, we have the surface here. It does not infiltrate like water, infiltrating through the soil. That does not happen. Any air that actually flows then or moves along the surface can be considered as wind. But winds would normally blow from high pressure areas to low pressure areas. You will not find winds blowing from low to high, no. Winds will only blow from high to low pressure. So winds are simply the movement of air from high pressure to low pressure. Some more important key points to remember, if you can make reference now to page 11 of your booklet. When we are looking at the topic on pressure, these are some of the key points that we need to remember. Number 1, or A, you're making reference to your booklet. High pressure will always result from sinking air, and it is usually associated with dry conditions. That is very important. You'll be required to make note of that very shortly. Number 2, or B, low pressure results from rising air, and it is usually associated with precipitation. Remember, for rainfall to occur, air must rise. So therefore, precipitation or rainfall will always be associated with rising air or low pressure. Cold air or high pressure is usually associated with dry conditions. By then, the air rises, it cools, expands, forms clouds, it falls. By the time it sinks, it's cool or cold. Therefore, dry conditions are associated with sinking air or high pressure. And the third most important point to remember is wind is simply the movement of air from high pressure areas to low pressure areas. You have a diagram there, figure 16. You can look at the diagram. The diagram is very similar to what I have put up here on the board. And that diagram explains those three important concepts that have been mentioned. Any questions so far to what we have looked at on the introduction on air pressure? Questions? No questions? Okay, if there are no questions, let's look at air pressure in the atmosphere and maybe something that you can do to try to check out what we mean when we talk about the column of air exerted on an area will give rise to a high pressure at the bottom and low pressure as we get up to the top. You have an instrument here, which is known as a skewer. It's like a paper clip, but it allows you to put the papers through. You have paper rings, which have been made, and then you make a hole in those paper rings. There's 1, 2, 3, 4, 5, 6, 7 paper rings. Make a hole through them so that you can put them into the skewer. Okay, you put the first paper ring at the bottom, and then you do the same. You place the others at the top of the others that have been placed at the bottom. What you will realize is, at the bottom of the skewer, it will contain the greatest pressure simply because of the weight of the other paper rings on top. So you can see here, the paper rings are a little bit more crushed or squashed compared to those at the top. So if you'd like to try that out, to check out the air pressure and how air pressure can actually be seen, you could use this particular maybe illustration or example here to help you with understanding that at the bottom, the greatest weight, therefore, high pressure. As we get to the top, the least weight, therefore, low pressure. Here is another example. If you are strong enough and you could try this one out. The vehicle itself, assuming that it's air and so much weight, you try to lift that up, you will find it's very heavy. What happens to this person here? So exhausted, couldn't even maybe stand up. This fellow is very strong to be able to even lift this vehicle. But see the effort that he's got to put in to make sure that the vehicle stays at the top. So here, the pressure is so great, so it's exerting down onto this person here. But imagine, perhaps Hercules. The outward pressure of this person here is equal to the pressure of the vehicle itself or the weight of the car here. So therefore, you have equal in pressure there. This person is able to lift this particular vehicle. Here, this person is not able to. Therefore, the car is maybe forcing him down. Maybe look at that as another example. You're going to try that one out? I don't think so. Okay, why do we need to study atmospheric pressure then? From studying atmospheric pressure, we are able to see the difference in air pressure, which creates winds also. So you see, winds are a result of air pressure or differences in air pressure. For us to be able to note about the different winds that we have on a local scale and also on a global scale, we need to understand air pressure because winds are associated with air pressure. We already found out that winds are simply the movement of air, and winds will always move from high pressure areas to low pressure areas. Another important reason for why we need to study atmospheric pressure is to do with the elements of weather or to do with the conditions of the atmosphere on a daily basis. Daily changes in air pressure is associated with weather conditions. Any change in the atmospheric pressure system is largely influenced by the daily conditions of the atmosphere at a particular time. So if we look at weather maps, the weather maps will also show you the highs and the lows and the movement of the air or air masses. And when we look at air, air has weight and therefore it exerts pressure, and therefore it's important for us, if we want to know about the weather conditions, to know about atmospheric pressure. Questions? No questions? Okay, we'll move on. What are the reasons for the change in the atmospheric pressure? Why is it that sometimes air pressure changes, or not sometimes, but every day, air pressure change? Why is it that air pressure changes every day? Changes in air pressure is due to changes in the atmospheric temperature. So when the temperature changes, the air pressure also changes. We already found out that warm air is associated with low pressure. So if it is warm air, what type of temperature are we looking at here? High temperature. If it is cold air, what type of temperature are we looking at here? Low temperature. So when the temperature changes, pressure will also change. So changes in air pressure is due to changes in atmospheric temperature. High temperatures will cause air pressure to be low, and low temperatures will cause air pressure to be high. So if the temperature is high, that means it is hot, the air is likely to rise. And when the air rises, what type of pressure will it create? Low pressure. When air rises, it will create a low pressure area. When temperatures are colder or cooler, then the air will tend to sink. And when the air sinks, it will create what type of pressure area? A high pressure area. The second statement on the reasons for the change in the atmospheric temperature is low temperature will cause air pressure to be high. Number two, changes in air pressure is also due to changing humidity. High humidity will cause air pressure to be low, and low humidity will cause air pressure to be high. Again, we should know the relationship between humidity and temperature. And also, here we are seeing the relationship between humidity and air pressure. High humidity will cause cause air pressure to be low, and low humidity will cause air pressure to be high. Perhaps I'll give you 1 minute only to make note of those. Not to copy the sentences word by word. See if you can summarize that in your main points and have that into your exercise book. Okay, have we made note of that information? Okay. Now we'll look at what do we mean when we talk about high pressure and what do we mean when we talk about low pressure. This information here we've already looked at from the introduction of our work on pressure from page 11. But to recap again on what we have looked at, note, high pressure is also known as anticyclones. It results from sinking air. When air descends, it is compressed and warmed. Sinking air is associated with dry, stable, or calm conditions. And high pressures are concentrated between 1,010 to 1,045 millibars. That we know already. What is meant by low pressure? Low pressure is also known as cyclones or depression. It basically results from rising air, and rising air is associated with unstable conditions. Low pressures are concentrated between 950 to 1,010 millibars. Again, that we have covered or gone through already. And I'm going to look at now the major pressure belts, and then I will leave you with activity to be completed for your homework. And your activity will be basically a construction of the globe in a circular format, and then to put in the major pressure belts around the world. We look at pressure. Pressure can be seen on a local scale, and can also be studied on a global scale. On a global scale, this diagram here might be a suitable diagram to illustrate the major pressure belts around the world. So on a global scale, on a large scale, there are certain areas around the world which are defined for high pressure or low pressure regions. On a global scale, we have the equatorial region here. This is the center, and the equatorial region, we are looking at 0 degrees and might extend to about 10 to 15 or 23.5 degrees north and south of the equator. Another very important pressure belt that is also distinct around the world is one which is found at 30 degrees latitude. (30 degrees north, 30 degrees south is also another very important pressure belt area. Another region which is also very important pressure belt area is the 60 degrees north and the 60 degrees south. And finally, the last region of a major pressure belt region or area is the 90 degrees south, 90 degrees north. These areas here, 1, 2, 3 to the equator, and then 1, 2, 3 to the South Pole, they mark what we call major planetary pressure belt regions. So if we look at the global scale, there are some areas that are distinct, and you can tell straight away what type of pressure would actually be found there. We'll start off at the equator. Because already we know that the equator is the area whereby the sun, when it is shining, the rays are vertical directly overhead the equator, the sun and the sun's heat is concentrated within this area. So the air in the or around the equator are likely to be warm. What do we know about warm or hot air? They will always rise. And because the air rises at the equator, what type of pressure belt would be common or would be found here? This is definitely a low pressure belt. So we have a major low pressure belt found along where the equator is. And that pressure belt is also known as the doldrums. Okay, the doldrums are known also as the equatorial low pressure belt region or area. And the reason for why this area has a low pressure is simply because it is hot around the equator, the air rises, giving rise to this major planetary belt, which is a low pressure belt at the equator. That's the first one. Okay, the air which is actually rising here, it will rise and it will also have to sink elsewhere. So most of it travels north and also south. By the time the air reaches about 30 degrees north and south of the equator, that air sinks. And when that air sinks, what type of pressure do you think it will create at about 30 north and south? A high pressure. So at the 30 degrees north and south, there is a distinct high pressure belt which is found, and those high pressure belts 30 degrees north and south are also known as the Horse latitudes. So when they talk about the Horse latitude, they're making reference to the high pressure belt area which is found around 30 degrees north and south of the equator. That's the second major pressure belt area. At the equator, high pressure, I'll correct that. At the equator, low pressure. simply because of the rising air. The air rises, sinks about 30 degrees north and south, creates a high pressure area. The high pressure area at 30 degrees north and south is referred to as the host latitude. Okay, in this region, some of the air is actually blown back towards the equator, and the blowing of the air back towards the equator now will give us the winds. But we are not looking at the winds yet. We'll come to that next. We are looking at the pressure belts. Meanwhile, some of the air which is actually sunk around the host latitude north and south will travel to the north. Some of them will be traveling back to the equator. Similarly here, in the southern hemisphere, some of the air will travel back to the equator. Some of it will travel to the South Pole. When the air, especially that is traveling towards the South Pole, because it's coming from the equator, it will be warmer than the air which is traveling from the poles towards the equator. Okay, perhaps I'll put in the two different colored chalk so that it will help us understand those air masses. Okay, here, the air masses. Remember, we mentioned that when the air sinks, what happens to it? It will move. And when it moves as wind. So some of the air sinking here will move back towards the equator. Meanwhile, over here, same. Some of the air will move back towards the equator, others will move towards the poles. Meanwhile, from the poles, the air which is actually moving towards the equator will actually meet. Where they meet, the latitude, the approximate latitude where they would usually meet is about 60 degrees north or 60 degrees south. Okay, upon meeting, if a warm air meets up with a cold air mass, what would happen? What would happen when a cold air and a warm air mass meet? The warm air will rise. Very good. So here, the cold air meeting up with the warm air, resulting then at about 60 degrees, the warm air to rise. And upon rising, what do you think? What type of pressure will be created here? A low pressure area. Similarly, here, a low pressure simply because the warm air will meet up with the cold air and the warm air rises, resulting in a low pressure area. Because here we found out that when air rises, it gives rise to a low pressure. Yes? Okay, the air which is actually rising here will finally cool and it will sink. And when it sinks, it will sink about 90 degrees north. Similarly, over here, the air will cool and sink. And when air sinks, it is associated with what type of pressure belt? High pressure. So we have a high pressure there and a high pressure here. And don't forget also, at the poles by this time, the angle of the sun or the sun's rays is hitting the poles at an angle. And therefore, the poles are cooler or colder than the equator. The temperatures are lower. And because of the low temperature, the air is dense, and because it is dense, it will sink. And the sinking air then will give rise to high pressure at the poles. Okay, so this diagram here generally illustrates the major pressure belts. Okay, let me give you your activities, and those activities I'd like you also to complete for your homework. You are going to be required to construct a global diagram, and that global diagram should show the major pressure belts. So a diagram similar to this. After you have completed the diagram showing the major pressure belts, I would like you also to see if you can explain the reasons for what causes the low pressure and the high pressures at the different latitudes. I have just explained to you, but it is now for you to put it in writing so that you understand what causes the high pressure and what causes the low pressure. Okay, to conclude our lesson for today, I'll quickly go through the information again on the board here to show us the major planetary pressure belts. And the major planetary pressure belts are at the equator, we have a low pressure, that is the doldrums. The low pressure is mainly as a result of high temperatures, warm air rising, giving rise to a low pressure area. 30 degrees north and south, we would find the next pressure belt, and that is the high pressure belt, the host latitude. This is as a result of the air coming from the equator sinking, giving rise to a high pressure. 60 degrees north and south, we have the low pressure belt, and the low pressure belt is as a result of the warm air and the cold air meeting. Warm air coming from the equator, cold air from the poles. Where they meet, the air rises, the warm air rises, giving rise then to a low pressure belt at about 60 degrees north and south. And the 90 degrees north and south, we have high pressure simply because of the low temperatures, giving rise to cold air sinking. And also, as a result of the sinking air, the air moves simply from the high pressure areas towards the low pressure areas. Okay, and with that, I'd like you then to complete the diagrams for your homework, and we'll check on that information in our next lesson. Good afternoon, and thank you, class. Okay, to the pilot teachers, our keyword for lesson 117 is pressure.